Hello and welcome. In this video we are going to solve the following question, which is given a sorted array, convert it to a balanced binary tree. So first of all, we know maybe about what is array, but maybe you don't know about binary tree. Binary tree is just a data structure that has the following properties. First of all is that if you want your binary tree to be balanced, it must have the following properties. The left subtree of the array is supposed to be less than the right subtree, and the root supposed to be less. Everything that is supposed to be after the root supposed to be less than left subtree, and everything that's supposed to be coming greater than the root supposed to be the right subtree. So, and the third property is that the left subtree and the right subtree of the tree must also be a binary tree. So these are the following. So let's get started. I'll open my terminal, my text editor, which is Vim. I just use Vim array to binary.py, and this is now empty. What I have to do, the first thing is to create a node, my node for the tree. I'm just going to create a class for that, a node, and then I can have my constructor here. The only thing that I need here is my data, and then I'll just self.data equal to data, and then self left, my left subtree equal to none, my right subtree also equal to none, left self dot right equal to none also. So this is all I need for my node, how to create a node. So now I can create my function that can help me to convert my sorted array to a binary tree. So the first thing that I have to do is just to define a function. I know it as let's say array to bs, array to bst, binary search tree. So I can just give the argument as array, and then what I have to do, the first thing is to check if not array, then I will return nothing. So let me explain first of all the logic for this. Is that, let's say we have this array 1 2 3 4 5. This is our array. So how we can do, we just know the basic properties of the binary tree. So it tells us that the left subtree is less than the root, but it's supposed to be greater than the it's supposed to be greater than the right subtree is greater than the root also. So this is what we can do. For that, we need to get the middle value that is supposed to be our root. So to get it, we just have to find the length of this array. When we find the length of this array, we divide it by 2. When divided by 2, it will be 3 is our middle value, and then 3 will be our root. After that, we have the left sub array and the right sub array. So we do the same thing for both of these. So this is a recursion task, so we have to do it recursively. So this is the basic thing. Let's continue. Okay, so I can just now find my middle value, which is equal to the length of my array. I will divide it by 2. That will give me the middle value, and then I just give that to my root. Means my root now is my root is the node of the array of mid. So this is now my node, my root node. This means I have this as my root. So I have to do this for the left subarray and the right subarray. For that, I can use regression. It can help me to do it very quickly. So I can just say root dot left, which is equal to, and then here it's a little bit different, but I hope you can understand this. What I can do here is just to give my array to binary tree, and then what I can do is just to give the array here, and I have to subtract things. I have to take everything till mid. So I have to take everything till mid. I have to do repeat the same thing, everything till mid. So it means here I will first of all take if it's not array, if not, then I will return if it is. I'll just find the length, I'll just assign the root. This is what it will do, the same thing. And I have to do the same thing for my right subtree sub array as well. So root dot right equal to array to binary, and then array of. Okay, so here what I can do, because this part can give me only the middle of my array, means the half of my array. So from now I have to start from mid, because I already get mid. I need to get from mid plus 1 now, mid plus 1 now till the end. So this is what I have to do. What I then finally do after these operations are done, I can just return my root here. So this is all we need for this function, and this is the basic idea how you can convert it. So let's now just try to print it to see if it is working properly as expected. For that, we have to write a function, and we need to know, for example, if we talk about tree, there are 3 ways to traverse a tree. We have pre-order, we have post-order, we have in-order. So we will be just using today pre-order traversal, which means we are traversing the root first, and then we will traverse the left subtree, and then we will traverse the right subtree. So this is what we will do. So it also repeats this task, so we are going to use recursion for it. So let's start. So I will define my function as pre-order. I'll give it as node because this will be my root, and I just check if not node, I just return nothing else. I just have to print my root node dot data, means the root, the node that has that data, and then I have to do the same thing for the left subtree and the right subtree, and then I just have to call my function here, pre-order node dot left, and then I'll do the same thing, pre-order, and then node dot right So that's all we need for this, and let's check if what we did is working properly and see what we have to do next. So let's just create a random array, and then we will just try to test through that one. I just call it as array, which is equal to, let's see, let's give the same thing 1 2 3 4 5, and then we will just try to give the root as our array, which is array to bs, and then I'll just give my array here as argument, and then I can just call my function here, which is pre-order, and then I give my root as my node. So let's try to run this code to save it, and let's execute it and see. Oh, it's worked properly. You can see the output here. So this is the output. You can see my root is, for example, if I'm here, I just explain here, go back to the question, my root is 3, so that means that we have 3 here, and after that we have 2, we have 4. 2 is less, so 2 will be printed first, and then 4, and then 1 also will be printed, and then 4, and then 5. So you can see this is the output. I have 3, 2, 1, 5, 4. This means I did my pre-authorizer and my tree is balanced. So this is the question, and I hope you understand the logic. So thank you for watching, and I'll see you in the next video.